can everyone hear me? Yeah, okay. So I'm a little bit like not a little bit, very excited about meeting you today. And as she says, like I'm going to talk about infrastructure from code, and I'd like to discuss with you at the end, like if this is something that we will blend into DevOps culture at the end. So like before jumping into the topic, I just wanted to ask you, like, how many of you have the boilerplate for starting a new cloud applications? Not many. So yeah, like everyone is starting from scratch then. So like how often do you update this, like with new services, with new approaches? Like do you update them frequently? No, like every 6 months, every month. Yeah. So like I actually don't have a boilerplate like most of the people here, because like every day something new comes up, and like it started to become less and less sense for having a boilerplate, because like there is now like very nice tool that appears every day, and just like you just want to keep up with everything, and at the end you just gave up having a boilerplate. So like this creates a decision paralysis for many of us. For myself, I can tell. Like there are lots of nice frameworks coming up, and there are like different cloud services. There are power-ups to the existing cloud services. There are different managed services. Like for now, like there are now 6, 7 managed relational database services today, like with Planetscale, Neon, and like it's popping up everywhere that like you are just like having a decision paralysis when you start a new project. So when you look at this cloud native landscape, you see that there are like lots of tools to choose from, and like it is becoming harder and harder to have a way of like, hey, I'm an expert in cloud, I just wanted to start in this way. So and this Kubernetes, I like this one a lot. So this Kubernetes dream that like everyone is looking for, it looks like a heaven, but at the end it turned out to be a problem. So like there's a new category emerging. Sean Wang says, like, I don't know for ones who know about him. He was the developer evangelist at Netlify, at AWS Amplify before, and now he's running a developer experience newsletter. I really recommend it. I cannot recommend it enough. So he says that like programming languages and cloud infrastructure should converge in some places where all the resources required by your application should be automatically provisioned by the runtime. So this is not now, this is a feature, but this is the feature that he envisions, and this is the feature of infrastructure from code is actually, chasing to. So he's calling it self-provisioning runtime, I'm calling it infrastructure from code, but this is actually the same philosophy at the background. Before diving into it more, so let me just introduce myself. I'm coming here from Ankara, Turkey here. I'm a dad to a 4 years old troublemaker, and I'm a product manager actually who can code. Like I was a developer before jumping into product management, and I always worked with technical products. I'm an AWS serverless hero, and now I'm a co-founder for Amt. So like Amt is one of those providers, but I'm avoiding any type of preferences to it whenever it's not necessary, except for the slide one, of course. So I'm also a community organizer at AWS community in Turkey. So we had the AWS community days last month. It was like more than 400 people. I know how hard to put together an event. So like I just want to give a shout out to organizers for this great event here. So in the rest of my talk, I will just like take you a journey in the history of shipping software, and I will just like go back to infrastructure from code, and I will just like let you see like where we are with infrastructure from code as of now. And I just want to discuss with you, as I said, like to what the future can hold for us. So this may be a little bit not accurate, but like, so this is how we are shipping software. So we started with servers and just like making connections to them. And like at the end, what we are trying to achieve with self-provisioning runtimes and like improvements in large language models is like, you will describe the app that you'd like to, and large language model will generate the code necessary with the infrastructure from code and provision it. So can this be the last part of the evolution? We will see. So like let's go back to to like the very beginning. So there was only code, like the assembly code, whatever, C code, like, and its primitives like the character arrays, strings, integers, whatever. And this code took us to the moon. So you can see Margaret Hamilton standing next to the code that their team is putting together for Apollo mission. So like this code was strong, this code was capable, this code was just like, you know, taking the ships, taking the rockets to the space. But like now, then we needed to do something like the client-server architectures and the, you know, I remember like sending my code to, like I was very newbie, but like I remember my sending my code to an FTP server in the back room with my big brothers, and like we were shipping sites like this, and it was quite fun actually. So like people were called webmasters back at then. Like there were nothing like DevOps or SREs or whatever. So then like the sysadmins era started like in the you know the 2000 like years, and like it created us better utilization, better deployment methods, and like invention of runbooks. And Chef and Puppet was leading the revolution there, and like they were the first proponents of the DevOps movement. So then the cloud entered our lives as an economical model. Like you were able to lift and shift your VMs to cloud, and like there would be like, this was the Ansible's you know, runbook for deploying a simple service, and it's, you know, it's quite lengthy but understandable, I can tell, to deploy a service. And now like there are more than 400 services. Sorry, 400 different types of EC2 instances on AWS for deploying different VMs. So like lots of people still use VMs, and this is still something that we are going through. And then containerization arrived, and the microservices paradigm actually emerged out of that. Like we were able to develop lightweight and small scope applications, and then that required like a faster development, but like they also required a synchronous execution, a synchronous message exchange between several services, so queues and the topics, and like such type of asynchronous, like the event communication arrived our lives after that. So this is again like deploying a container to a service, and like, you know, with Terraform. And it is still lengthy, as I say. Like this is how it should be, but like it's kind of as a non-developer, it bores me. But no offense, like it is required. So and then Kubernetes arrived. Like it was an orchestration and management layer to handle all complexity, they said. But at the end, it is still very complex for many people, including myself as a serverless people. It's a DevOps dream, but we saw how that dream went up. So like again, it's still lengthy, you know, script to deploy some Kubernetes clusters to Google Cloud, and just like you need to define everything one by one. So let's enter serverless. Look, this is like coming to my area, but like when it says serverless, like it becomes so vague at this point. So like when you call something serverless these days, it's like serverless, but like is it marketers serverless or is it developer serverless? Because like the serverless term is actually quite damaged by anything that's happening by the marketers. So, but the real serverless, in my opinion, is actually, you know, it's the case from 0 to infinity, whatever the cloud provider's ceiling is, and it is high availability because you don't manage to make it like robust. So the cloud provider takes and handles this, and you pay per use. You don't need to pay. You should not pay something in front, and it should be event-driven. So there shouldn't be something always on. So this is my definition, and still with AWS SAM, this is like a defining an AWS Lambda function that gets triggered by another DynamoDB stream, I guess. And it is still a very lengthy definition. And this is like I just wanted to mention about the confusion around serverless. So like AWS, I'm talking as an AWS hero, like two services that they call as serverless, the open source serverless, which starts with like the almost $700 to start with because you should provision some resources, and Neptune serverless is a graph database, and it starts with like $43 per month. So like when you look at this, it is like, hey, if this is serverless, like what's going on with the, you know, Lambda and everything, but like there are also pure, and the serverless doesn't need to be only fast. Like I'm not telling that like there shouldn't be any serverless database, or like DynamoDB is pure serverless, S3 is pure serverless, but like the serverless definition is actually, getting some damages even from AWS when it comes to, pricing, because they just want to call this serverless, but they also need to keep something, keep some services alive to actually respond. But this is creating some confusion, in my opinion. And so like the serverless adoption kind of failed because it turned out to be serverless. It turned out to be config-full. Like you do lots of configs and you just like config, provisioning resources kind of became problem, like a problem in non-serverless workspaces. So it took time. Like you need to understand like at least SAM or CDK or Terraform, let's say, and you need to really be proficient about these infrastructure as code tools. But in my opinion, the true promise of cloud should be about like using cloud as an utility, using like cloud as like you were using electricity, but like it's not happening like that in serverless either. And it is like serverless also requires a learning from like event-driven architecture perspective. And it is I don't like this is always necessary for like the modern applications, but this is not helping people like who wants to just lift and shift their applications to serverless, let's say. And this is like made the serverless adoption not failed maybe, but like I can tell not as much acceleration that we would expect back in like 2019. So even like this Kubernetes and serverless war goes on, we are all drowning YAMLs, and the CDK came to rescue about that. So instead of just providing YAML files and the configuration JSONs and everything, they came up with like the writing TypeScript or Python or whatever runtime that you prefer to provision resources. This is still like this is actually I liked it a lot, like what we achieved with CDK. But yeah, this is still like you need to think about this, and you need to think about like how to connect services. But the required thinking of how to couple different cloud services are still there. And this is actually damaging the developer productivity. So when I say developer productivity, what I mean is that it's not about just like not writing YAMLs. So it's not like this, but like there should also be like high fidelity development environments. I don't know how you are creating a development environment, but it's a problem in almost every company that like building development environments which are actually very identical to the production environment. So like everyone is trying to like there is local stack for replacing the services in local, so that actually you can build the developer experience in your local, that people are just creating accounts per developer, which I really think as the way of building developer productivity for individual developers. But like we still couldn't actually manage to have high fidelity development environments. Like, and please tell me if you managed to have this in your company. So like the local development with favorite tools, like everyone has to choose something if they want to stay in the better development environments. And like it's not like I just wanted to go with my own S-lint or like the things. It's not easy to do local development. So integration testing is like another issue. So you need to do hexagonal architectures, and it's it's a kind of a mindset that you should arrive before you build the systems. And integration testing with serverless services in specific is not an easy problem to solve. So at the end, like if you are spending more time on setting up your infrastructure than the value that you will provide to your customers, it means that actually your developers' productivity is still needs to be improved. And so let's talk about infrastructure from code a little bit. So infrastructure from code is kind of trying to disrupt not disrupt, maybe help infrastructure as code people with something different. So it is based on the idea of like this cloud platform automatically infer the infrastructure requirements of your application from the business logic, and it provisions, manages on cloud, and optimizes the resources on cloud. So what I mean by optimizes is like let's say, like we are, like some cloud provider is provisioning a service for you, just like looking at your business logic, and they deploy a serverless function for you, and they can just like look at the code, and they can look at the traffic, and you can say, hey, this is taking lots of traffic and becoming cost inefficient, so let's switch to containers. And this is becoming even like more like cost inefficient with, let's say, Fargate on AWS. So let's switch to VMs and so on. And like, let's say that there is a fail in your region. This platform should actually fail over to other regions so that actually you should be continuing to serve your customers. So this is the vision. Like, I'm not telling that like everyone is doing this, but this is what infrastructure from code is aiming to do. And this is how it looks like. And this is the only part that I am going to talk about. And this is like when you want to define an API, it's just you are defining an API with an SDK. And it's like, hey, here's my get endpoint. And in it, like I am just like making a database call to my database. And I'm returning the results. So it's like at the background, so it is provisioning an API gateway. I'm talking about AWS here, and it is taking another AWS Lambda function, a DynamoDB, and connecting them with correct IAM permissions, and you don't need to think about this. Like, this is kind of a approach that infrastructure from cloud is doing. So we are considering cloud as the new computer, and since we are on the cloud, we are building everything on the cloud for cloud applications, and infrastructure from code is actually the new operating systems offering new primitives, which are, APIs. Instead of thinking about primitives of old code, like we will still come to think about them, but like the API will be our primitives, scheduled tasks, like batch jobs, events, and the databases, blob storage, WebSockets. Like, we should speak in the language of new primitives with the cloud applications, because the other problems are already solved, so we need new abstraction layers. So this is actually taking us to the closer to the true promise of cloud, like which is like writing only application code without running in YAMLs. So let's look at this. Like, what are the other what is the state of infrastructure from code as of now? So there are like 4 different approaches. So in order for these cloud providers, like new cloud providers, understand what your application is doing, you need to help them. So the way to help those is like, using an SDK, or like using annotations in different languages, or like making this hybrid. And there are also new programming languages appearing just for this purpose, because like people think that new programming languages would be a cleaner start for this new paradigm. So VR and Nitric is using SDK-based. So we are providing you SDK, and you are just like taking advantage of it. I already explained. And like model apps, like this code is from Model, and the Cloto is using annotations to define what this code is matching in the infrastructure. So Model is a Python-based, and they are like really helping people in terms of building data applications with intensive data, and it's targeting people like data people doesn't have the required cloud knowledge most of the time. So they are enabling them for building cloud applications with their data applications, with their data mindset. So like here in this example, you see like you are seeing a batch job that's defined as a function which is being called like every day. So you can just like go to some website, and this is already deployed on behalf of you with annotations. And with Anchor and Shuttle, Anchor is Go-based, Shuttle is Rust-based, so you can check them out. So with Anchor, like in this example, you are defining, like it's a hybrid approach. You are just defining something with annotations like here, so you can say that this is an API in the Go code, and you can also use Anchor's database connector, so that actually it's coming with the SDK, so that you can make requests to their database. So it's like both annotations and SDK usage. And there is also new programming languages. So Winglang by Monada team, if you know about them, is building a new programming languages called Wing. And they're just like, they think that like JavaScript, Python, yeah, it's good, but we need a new programming language because our abstractions require some dedicated language to support this. So they came up with this new programming languages. Darklang is also kind of similar, but it's more like a drag and drop based. And Dark is actually the first infrastructure from code provider. So they are around for 2000 since 2018, I guess, and they also have a programming languages. So you may think that like this requires another thing to learn, and I agree. But like they think that this is the way of start inventing something new. And like I just wanted to talk about infrastructure from code vision. So this is the vision that everyone is somehow trying to arrive. But this is like not that I can say for everyone, but this is like some parts of it there, some parts of our needs to be there. So like it should be self-provisioning, as I say. It should be self-instrumenting. For example, like none of them has this. Like you should be able to put the open telemetry tracing on this automatically, so that actually it provides open telemetry compatible data to any data resource, and it should be self-documenting when you Anchor is doing good in terms of this, like you can see where the visualization is going. It should be self-testing. You should be able to test this, and you should be self-auditing and self-managing it. And self-optimization is something that like you should be like, for example, we have now have magic number that we are tracking attempts. Like if a service gets like more than X number of requests for half an hour, let's say. It's very manual for now. We are just learning how to do this. We are just switching them to containers because like it doesn't make any sense for them to be in serverless for this much. So because like this is becoming cost inefficient for customers. And like the biggest actually vision is like self-upgrading. So you should be able to take an application written by infrastructure from code abstraction, which is deployed to AWS, and we should be taking this next to Azure with this portability. But this is not there yet. But this is what we want to arrive. So like the notion of cloud-native applications should be replaced by native cloud applications. I know that this is creating lots of confusion, but like instead of just like trying to build services at your local and try to migrate them to clouds in containers, why don't we just use cloud services and just build cloud applications from day zero? So for example, S3, if you know Amazon S3 is like, it's like a cloud applications from the beginning, and it's like 15 years old. So they didn't think about how S3 would work in the local computer. So they built S3 only for cloud, and you can only use it with APIs or not, so like the cloud formation. So like people should come into this mindset of like building native cloud applications with native cloud resources instead of just like trying to port the application that is working on the local and just trying to port to cloud. So what should be like, I think about this, what does this team mean to DevOps? So it's like an autopilot for your cloud infrastructure. So you should still, take the control of it whenever you want, but like you should be leaving it to infrastructure from code and for happy paths, and like you should be able to get into scene whenever it's required. So it gives like in the serverless movement, like we were saying 3 years ago about serverless. Serverless is not no ops, and I am telling this the same for infrastructure from code. It's not no ops. It's actually less ops, and it's actually more time for value for your customers, more time to communicate internally about how systems work, more time to monitor systems up and downs and take control and like understand. So that you will be able to take control when necessary. So this is kind of we are still trying to invent this. So we are not actually capable of doing this like in a robust way. But I really think like the last step in the evolution we will just speak with some LLM, like we were speaking with ChatGPT today with some stuff, and like we'll be able to trust LLMs to deploy an application to an infrastructure from code provider with no human intervention, so that like you just describe the app you want, and this app turns out to be an app that is serving millions of customers a day. So this is the kind of the feature that we are chasing for. And if you know about Small Developer by Sean Wang, like you can check out this. So he developed a GitHub application on his GitHub about like he's describing the app that he requires to see, and this app turns out this gives him the app that should be deployed to the model, in this case, like the one that I talked about, Python. And it is working really, really scarily good. So like it just gives you an app that's deployable to clouds with no human intervention. Like you just need to copy the code to a model and just like deploy, and it is working. So it's kind of happening now, but like I don't know if it will be a mainstream thing. So thanks a lot. I think I still have 5 minutes, but I came to the end of my presentation, so I will be happy to take the questions.
Okay, so thank you very much. And now it's again time for your questions. So the same principle, if you have a question, raise your hand and we will give you a microphone.
Hey, thank you for the presentation. I liked it very much. I would like to address the chicken egg problem here. Like, where do we run the code for infrastructure from code?
So, like infrastructure, in our case, let's say I can only talk about like I only know the internals of our application, but like this should be similar in the other stuff. So like we are actually having a whole farm of AWS accounts at the background. So when someone signs up for Ant, so we are just like assigning an AWS account for them, and like we are just like pre-provision some of the resources for them, so that like the first deployment becomes fast. And then like after that, when they like we are giving you a sandbox, so you have multiple environments attached to same AWS account for you. You have sandbox, you have stages, and when you say this is production, we are creating another AWS account so that it won't be affected by account-based limits. And so at the background, all these infrastructure from code companies are wrestling with the cloud giants about like, hey, provide us like 1,000 more accounts. So this like we have a dedicated account manager at AWS that gives us accounts constantly, and this is how it works actually. So like all like the thing that we should understand that like infrastructure from code cannot be another Cloudflare or AWS. It's about another abstraction that actually takes down to AWS in our case, and like the other providers also provides Google Cloud. Actually, Anchor does this, so that actually you are using those cloud providers more efficiently. This is actually coming from that perception. So like abstraction layer, but you don't need to know what's going on at the background. And if people want to know, we are explaining them. We have our diagrams and everything, and we are also able to deploy to their AWS account so that they can see it. But yeah, this is how it works.
What I found interesting was the page where you showed all this, like I'd say a compressed term would be self-governing of the code, of the application coming from the code. But the only thing I'd have a problem wrapping my head around is how would the application from the code or whatever runs it know how to provision it in case of how many resources would it need to start initially, how many resources is a limit that makes sense, stuff like that.
Yeah, like there is, yeah, thanks, this is a very good question. So there is no type of a control panel for people to, intervene with, but like if when we deploy to their AWS account, they can actually intervene with. So they can actually increase the, concurrency of a Lambda function. They can check out like what is deployed, and they can touch it and they can just change it. But like as principle, like we start with a serverless architecture with like Lambda, DynamoDB, and so on, and S3. So we are just coming up with our default settings, and then we are upgrading them accordingly if people don't ask about it. And if people ask about it, we are just starting working with them. We are just like considering them as design partners rather than customers, about like, hey, yeah, let's migrate to your account, so your account is getting more requests, so let's switch you to containers type of stuff, but like we are just making the automations of those for now. So like, just to answer your question, there is no control plane for our customers at the beginning. And I should be, honest about it. Actually, our first users are not maybe from this room, because like our first users are just more like a front-end developers or small startups who just want to go to the market very fast, and like this is how they approach. They don't care about like how this application will be served to millions of people. There's one customer from Brazil which serves like 60 million requests in a day, and they are really into it, and like for them they are deploying to their AWS account, and they are able to change the configurations if necessary.
Hey, Stepan Petensky, you spoke about the happy paths, like what I have seen so far when you're providing this kind of magic solutions. Usually it really breaks down on the set parts that the developer doesn't understand how it's actually put together. The more you abstract, the farther away they get from it, and like the more it takes them to actually find out why it is failing. And that's the most important thing, like being able to fix stuff fast, right? So what's your solution in there?
So as I say, like people are able to see the cloud formation that we are deploying, so they can understand actually what we have done for them, and they can work on this, and they can change the anything in it. So like we are not hiding that, hey, this is a magic box that gives you infrastructure, but we are not showing it when not asked. So this is actually how it works. So like many people just don't care. Some people just want a black box. Some people want a black box that you can see inside. So if people want to see inside, we are showing them, and they are able to actually intervene, make it change. It's actually AWS at the background for us. So like there is this Scooby-Doo thing that like infrastructure from code. It's actually when you change it, like it's actually pre-provisioned resources on AWS for you.
Okay, I think we are running again out of the time. So thank you very much for your talk, and thank you very much for your questions.
Thanks a lot for having me here.